Okay, we're going to go through one more example of each of these two different types with graphing and substitution so that we feel like we have everything covered. So example 3 here, I have 2x plus y equals 5 and 3x plus y equals negative 5. So the issue here is this is not in slope-intercept form, which makes it easier for me to graph. Slope-intercept form being y equals mx plus b, where m is our slope and b is the y-intercept. And so I'm going to have to move our equations around a little bit. If we notice, I have a positive y on both sides. So really all I need to do is move the 2x and the negative 3x. So I'm going to do this separately. So first I'm going to do this one. So I have 2x plus y equals 5. To get the y by itself, I'm going to subtract the 2x on both sides. And we are left with y equals, which is our goal, to get y equals, and then negative 2x plus 5. So based off of that equation, my y-intercept is 5, which occurs at 0, 5. So I'm going to plot that point first. 0, 5, 1, 2, 3, 4, 5. Here we go. And then my slope is negative 2, which when we're graphing, negative means we're going to go down 2 and to the right one. I'm going to go down 2 to the right one, down 2 to the right one. And I'm going to do that just a few times to give myself an easy way to make nice pretty lines. Again, just ballpark it, sketch it out, do the best you can. Did not quite turn up in the correct place. I'm going to shift it just a little bit. And adjust these. Oh dear. Okay. There we go. Okay. So there is my first equation, and then my second equation is that negative 3x plus y equals negative 5. So to get that 3x to move to the other side, I'm actually going to add it. I'm going to do the opposite of the sign that's in front of it. And so this 3x's on the left-hand side cancel out. And we're left with y equals on the left, and then 3x minus 5 on the right-hand side. So that makes my y-intercept negative 5, so it's 0, negative 5. And our slope is 3, which when we're graphing means we go up 3 and to the right 1. So I'm going to plot my point at 0, negative 5. 1, 2, 3, 4, 5. And then go up 3, 1, 2, 3, and to the right 1. Up 3, 1, 2, 3, and to the right 1. And the more you do this, 1, 2, 3, to the right 1, you'll notice where your lines cross, and you'll be able to identify that point more easily. Sometimes I have to adjust this just a little bit. There we go. Okay, and seeing where those lines cross, our solution is that x is positive 2 and y is positive 1. Okay, so looking at our last example here, this is a substitution question. So we are going to look at taking this y value of 3x plus 2 and replacing it with the y in the second equation. Now this is, again, why I stress using parentheses, because I see a negative symbol in front of that y, and I know that's going to cause some changes to how I execute this problem. So I'm going to rewrite that second equation, 3x minus, and then where I see the y, I'm going to put parentheses and insert the 3x plus 2, and close parentheses, equals negative 2. Now that negative symbol or the subtraction symbol in front of the parentheses is going to distribute to each piece inside. So you can think of it as a negative 1 if you would like. You don't have to, but you could say negative 1 times 3, negative 1 times 2, or just take the negative symbol and put it in front of each item. So then we have 3x minus 3x, and then the negative symbol also goes to the 2, minus 2 equals negative 2. And you might start to notice, well, this looks a little weird. 3x minus 3x, well, those just cancel each other out and they don't exist anymore. And then we're left with negative 2 equals negative 2. This is what we call our special cases. And with these special cases, there are two possibilities. The first thing you have to do is ask yourself, is it true? And then based off of that, you'll find your answer. So if it is true, or yes, it's true, then you have infinite solutions. If it is not true, then you will have no solutions. So looking at negative 2 is equal to negative 2. Is that true? Yes, it is. So our answer is infinite solutions. An example of no solutions or something that is not true would be a statement like negative 2 is equal to 5. Is negative 2 equal to 5? No. Therefore, it's not true.